Howdy there, ladies and gentlemen. My name is Aiden, and today I'm going to be teaching you guys how to create a Outlast-inspired character controller, and this will be part of an Outlast chase sequence, or an Outlast-inspired chase sequence that we're going to make here over the next couple of videos. But this first video, we're going to focus on project setup and the base character controller. So, first things first is project setup. I have created a new project using Unity 2022, their latest at the time of this video release. We're using the universal render pipeline. We have the basic volumes for post-processing that they provide. Art is by the amazing Cinti Studios. We have their Polygon Horror Asylum pack right here. And quick overview, I went ahead and created a little scene of let's go into full screen here, a scene of our security office with a deceased security member who was tragically murdered by an inmate. How romantic, I know. And here where we have a generator that will later in our chase sequence part of the series be turned off, all lights will shut off and these siren alarms will turn on. Over into project layout, I went ahead and made a project folder. You would call this whatever your game or project is called. I just called it project for sake of this video. I created a prefabs folder and a scenes folder. In our prefabs folder, I just saved this siren that I made real fast. And of course I have our sample scene that I created here. So, first things first, we're going to need to create our player. So let's go ahead and right click and create a 3D capsule. Let's call this player, and let's first reset its transform to be at the center of the world. Next, I'm going to remove this mesh renderer and filter, and in our collider, I'm going to set its center Y to 1. This will let the capsule collider be flush with the ground. I'm also going to change the radius here to 0.25. And we're going to leave the height like so. So now we have our capsule collider. Let's go ahead and get our character controller created. So we're going to be doing a rigid body based character controller. We're not going to be using the character controller provided by Unity. It's just kind of a preference thing. I like to make rigid body based character controllers. So let's get on with it. So I'm going to minimize this capsule collider and add a component. We'll add rigid bodies. It's already there. Perfect. And here we're going to do a few things. I'm going to set the collision detection to continuous dynamic, and I'm going to freeze the rotation on all axes. So that's about it for the rigid body and collider setup. Let's go ahead and create a script. So in our project folder, I'm going to create a new folder. We're going to call this scripts. And I like to be organized, so I'm going to create another folder called core. This is where all of the core stuff for our project is, and we can later have a folder called utility for any utility classes and so forth. In this core folder, let's create another folder, and let's call this player for organization's sake. In this player folder, I'm going to create a C# script and call this runner player controller. And then we will edit this in the script once it is compiled. Okay, so now we are in our controller script, and here we're going to create some variables to start off with. So of course we need a reference to our rigid body, so we're going to say private rigid body RB. Next, we're going to cache our current speed. This is because we want to be able to walk, run, and later down crouch. So first, let's add just basic walking and running. So private float current speed. Now let's create floats for our actual individual speeds. So public float walking speed. Then let's control deduplicate that and rename walking to running. So now we have a walking speed and running speed variable. Now we can get into actually creating our character controller. So first of all, we're going to add a start function. In the start, I'm going to cache our rigid body component. Next, we're going to add an update function. So I'm going to go down 2 lines and add update. In here, for organization's sake, we're going to create a new function for handling our input. So I'm going to say handle input. And then below the update function, we're going to add private void handle input. And in here, we need to get our horizontal and vertical axes from the Unity input system. We are not using their new package. I would like to, but for simplicity's sake, we're going to stick to the standard one. And for those more advanced users, they can implement the new input system accordingly. I do favor it if you are new to Unity. I would highly suggest researching that new input system, as it is very, very handy and easy to work with, and it gives you a lot of modularity. So first thing, we're going to add our horizontal and movement inputs. So we're going to say float horizontal, and we're going to equal this to the input system dot get axes and horizontal. We're going to end this line off and go down a line and make a float for vertical. And this is going to equal input.getAxes, and you guessed it, vertical. Up here, I'm going to add a comment just so we can kind of look back and reflect. I'm going to add get horizontal. Oh, my thing was there. Get horizontal and vertical input axes. I think it's axes, not axes. It's very fitting for the style, but not what we want. Next, we're going to cache our input to later use down the line. So we're going to go up here and add another private vector3. Let me not add spacing. Private vector3, and we're going to call this input. A little note, I'm adding underscores before all of these. This is just my convention and how I've done it. You do not need to though. So down here under the horizontal and vertical inputs, we're going to say this dot input is equal to new vector3. On the x-axis, we're going to do horizontal because horizontal is going to be the A and D keys. The y-axis, we don't want to fly anywhere, so 0. And the z-axis, we're going to do vertical. We can end this off, and we are all set. So next, we're going to create a late update function here. And in here, it's going to be pretty simple. We're going to say rb.velocity is equal to transform.forward times our input. And since we're going forward, that's going to be the z-axis, so input.z times our current speed. Then we're going to add this to another parentheses of saying transform.right times input x, or input, sorry, let me do my naming, input.x times current speed. So if we test this, first and foremost, this will not work. Why? Because our current speed is going to be 0. So let's handle our speed now. So to do this, we are going to make another function called private void handle speed. And in here, let's make a float for our target speed. And we're going to equal that to our walking speed. Okay. Next, we're going to say if input.get, I don't know why my autocorrect did that. If input.getKey, I don't know why it's doing that. Let's fix that in a second. If getKey keycode.left shift to sprint, and then I don't know why it's doing this. If left shift, then we're going to say target speed is equal to running speed. And then let's finally set, let me add a parenthesis. Then we're going to say this dot current speed is equal to target speed. After the input, we're going to handle our speed as well. So now this should work pretty well. Let's go ahead and minimize. So in our player, let's go ahead and click and let's drag on our runner player controller. Let's set our walking speed here to 5, or sorry, not 5, let's do 2. I think because we want this player to move very slowly. We don't want to make him, Quake mode running around. So let's do 2 for the walking speed, and I think 5 for the running speed is a good one. Next up, if we hit play, we won't see anything because we have no camera. So let's go ahead and create a camera, and let's set its y-axis to 1.5. That'll make it to where it's kind of level with where the head would be. I'm going to center the player by the door here. And then let's set our near plane on our camera to 0.01 for now, just so we don't clip through objects. And let's enable post-processing to make it look a little bit pretty. And then we can go ahead and enter game view and hit play. So in game view, we can move forward, left and right. Everything works fine, but I would like to clean up this code a tiny bit. So let's exit here. Let's go back to our script. So in here, let's do something else. Since we're going to have crouching, I don't want to have a bunch of booleans to toggle through, so we're going to make an enum. We're going to make a, down here, public enum, and we're going to call this player movement state. In this state, we're going to add walking, sprinting. And then up here, above our public float, for our running speed and walking speed, let's add a public player movement state. We'll call this movement state. Now, we don't want other scripts to be able to modify this. So I'm going to say get private set. This only allows other scripts to return it, but cannot set it. So only this script can set this parameter. So now what we can do is instead of doing this, we can delete this and we can say, actually, let's do this in the input section. Let's not do this here because we're going to be handling input there. Let's just clear this public handle speed out, or this private void handle speed. Below the this.input is equal to new vector3 within our handle input method. Let's go down the line and we're going to say if input.getKey and keycode dot left shift. If we are holding down left shift, then our movement state is going to equal player movement state dot sprinting, else movement state is equal to player movement state dot walking. And then in our speed, we can simply do float target speed is equal to this dot movement state is equal, if we're walking, we're going to add a question mark. I forgot what it was called for a second. If we're walking, we're going to do walking speed, otherwise running speed. Now, I want the walking speed and running speed to smoothly transition. So let's add another float, and let's call our float variable, and let's call this speed smoothness. I guess we should say speed transition speed, but I'll just call it speed smoothness for now. Here in the handle speed, we're going to then simply do this dot current speed is equal to mathf dot lerp. Our source is going to be the current speed, so this dot current speed. Our target is going to be our target speed, and our time is going to be speed smoothness times time dot delta time. This allows us to factor in the time scale of the whole game. So now we can smoothly transition from walking to running. Let's go ahead and save that and go back into our game. So this isn't going to change any parameters. This is just going to make it a lot cleaner, and let's just make sure that we can walk and run. Previously, before we made this change, you could have walked and run. We didn't really test that because it went over my head, but let's test it now and make sure that we can in fact walk and run. So entering game view here, let's hit play, and we're going to walk. Uh-oh, this doesn't work. Why? Because our speed smoothness is 0. So let's go back and change speed smoothness to 5. I think that's always a good number for these kind of things. Let's go forward. Cool, now it's run. Awesome, it works. We can run forward, back, left, right, and we can also just walk. Perfect. Next up, there is going to be one problem with our velocity here. We need to take in the y velocity so that our player is affected by gravity. So what I'm going to do instead is I'm going to cache our velocity up here. We're going to make a private, private vector 3, and we'll call this velocity. Instead of doing rigid body velocity is equal to this whole clump, I'm going to just remove RB velocity, and we're going to set underscore velocity is equal to, and then our whole calculation here. Below this, we're going to add velocity dot y is equal to our rigid body's y velocity. This is so that gravity, since gravity is applied to our player's or our rigid body's velocity, if we set our rigid body's velocity to this, it will not take into account gravity. So we're going to just cache it and say, hey, our y for our velocity is going to equal our rigid body's y. Then below this, we can simply do rigid body dot velocity is equal to velocity. And now gravity will take into account. There is no way to really see this in game, but if you have things like stairs, if you have your character falling off, cliffs or whatever, then you will be able to see this change. So that is about it for the speed and the input. We can go ahead and Control S save, but now we have another problem. Our character's head doesn't work. So we need to make our character able to look around, and we want it to happen smoothly. We want to, make the controls not as responsive to give the player less control, further enhancing the horror factor. So we're going to right click on our player folder and create another script called runner player camera. Now, before we actually edit the script, we're going to attach it to our player, not our camera. The reason for this is I personally like attaching all of my scripts to my player so it's all in one spot and we don't have scripts in the children. Now, why are we doing this camera script separate from the player controller? Well, because we want to handle things like player leaning in the future, looking behind us as we run, and we also want to handle field of view. So I feel like that's going to kind of crowd our player control script, so it's better to just make it its own camera script so that anything relating to the camera is handled in the camera. So let's go ahead and edit the script now. And in here, we're going to create some, you guessed it, variables. First, I'm going to create a private reference to our runner player controller so we can get our current movement state, underscore controller. Next, I'm going to create a reference to our camera. So public camera, cam. Then we want some sensitivity stuff. So public float sensitivity. This is for looking around. I'm going to add a header for organization and call this sensitivity. And then we'll add a float below the sensitivity variable, and we'll say public float look smoothness. This is the smoothness at which our player will look around. So first things first, in start, we're going to cache our controller. So, AI is automatically correcting here. So we're going to tab controller is equal to get component runner player controller. Next, we're going to add an update function. And the first thing we want to do is create a handle input function. This is going to handle the input for our mouse. So let's add another function, private void handle input, exactly as we wrote right there. And in here, we're going to do float x is equal to input.get axes mouse x, and we're going to multiply this by our sensitivity. Because our mouse x-axis is going to return +1, -1, or 0, we want to multiply that by our sensitivity to give us higher, motion in our camera. Otherwise, our camera is going to look around very slowly. So next of all, we can do float y is equal to input, can't spell, .get axes, and this is going to be mouse y, capital M. This is case sensitive because it is referencing the Unity input keys. So we're going to do times sensitivity. There we go. Next, we need to cache our mouse input because we're going to be doing some smoothing here. So we're going to add to our variables a private, let me actually, for consistency, add it to the top of our script. Private vector3, we're going to call this mouse input. And we're going to say this dot mouse input is equal to vector3 dot smooth damp. We're going to smoothly interpolate from our current mouse input to our target. So with the current being, mouse input, our target being a new vector3 with the x being x, y being y, and z being 0 because we're not going to be rolling around. After this new vector3, we're going to add a reference to a mouse velocity parameter, which we're now going to create. So below our mouse input vector3 variable, we're going to add a private vector3 mouse velocity. And after this reference, we're going to add a comma. We're going to add look smoothness times time dot delta time. And I added a comma on accident. Let's remove that. Perfect. So now we're going to smoothly damp from our current mouse input to our target, and now we can actually do some rotation stuff. So we're going to add in our update below our handle input a handle rotation parameter. And this one is simply going to do private void handle rotation. And in here, the way we want our player to rotate is we want our camera to only look up and down. Oh, we're in game view. Our camera should only look up and down while our actual player rotates left and right. We don't want the camera to look left and right because whichever direction we are facing, we want the player to move forward. So we are going to want to move our player left and right. So in here, we want to say this.cam.transform.local rotation, because it's a parent of our player, is equal to, and then we need to actually rotate our camera. So we're going to go back to our handle input, and this is where we're going to cache some more values. I forgot to add end colon there. We're going to add another vector3 private variable called vector3, and we're going to call this camera rotation. Okay. We're also going to add one for player rotation. Lowercase p. Before we assign our mouse input variable and our handle input, we're going to add camera rotation.x is going to minus equal this.mouse input.y. Why are we doing minus equal instead of plus equal? Well, because this will invert. If we do plus equal, it'll be inverted. So as we move our mouse up, we will look down. As we look down, we will look up. That is because in our camera, as we look up, it's going to be a negative value, while as we look down, it'll be a positive value. So let's go back in our script. We also want to do one more thing. If we keep this code as such and we look up, our player will look in circles 360 on the x-axis, making our head quite literally spin. So below this camera rotation x, we're going to add camera rotation.x is equal to mathf.clamp. We're going to clamp the current camera rotation.x value with the minimum being -90 and the maximum being +90. This prevents our camera from looking more than 90 degrees and looking less than negative 90 degrees, not allowing our head to spin anymore. Below this line, we need to make our player look left and right now. Instead of doing camera rotation, we're going to say player rotation dot y plus equals this dot mouse input dot x. Now, in our handle rotation function, we can say camera dot local position, or local rotation, I apologize, is equal to quaternion dot Euler, and we can input our camera rotation parameter. Below this, we can do this dot controller dot transform dot local rotation is equal to quaternion dot Euler, and this will be our player rotation. We can end this now, save, and go back into our game and see if this magic works. So in our player script, let's assign our camera. For our sensitivity, I'm going to say 5, and our smoothness, the magic number 5. Let's go back in game and hit play. Now you can see we can look around and it's very smooth. But now we can simply walk around, we can even run, and it looks pretty good. So now let's add some field of view changes whenever we run and walk. This will make it to where we seem like we're going faster and we can create intensity during our future chase scenes. So let's exit play mode and go back into our script here. We're going to add another function called private void handle field of view. And in this function, we're first going to add this before our handle rotation, handle field of view. Actually, before we start populating this method, let's create some more variables. Here we're going to create another header and call this field of view. And I'm going to create a public float walking FOV. We're going to duplicate this and then make the next one running FOV. And then we'll make one called FOV smoothness. We want everything to be smooth so it's not snappy and instant. So now back in our handle field of view method here, what we can do is we can say, hey, float target FOV is equal to controller dot movement state is equal to running or sprinting. So if we're sprinting, we're going to set our target FOV to the running FOV. Or did I call it sprinting? Yeah, running FOV. Oh, I used the wrong symbol. Sprinting, question mark, running FOV. Otherwise, we'll do our walking FOV. Next, we can say this dot cam dot field of view is equal to mathf dot lerp from our this dot cam dot field of view to our target field of view, with the speed being the FOV smoothness times time dot delta time. Let's end that line off. And now we can simply hit save and go back into our game, and let's see the magic. So now that we're back in our editor, we can go to our player now and we can assign our FOVs. We want the player to feel kind of claustrophobic whenever they're not walking. Or not claustrophobic, but we want to make their field of view not so wide so that they have to focus on what's in front of them. So the walking FOV, I'm going to set to 50 instead of 60. The running FOV, we want it to be a little bit wide while we're running because we're panicking and we're hooking around more. So I'm going to say 65. Our smoothness, guess it, magic 5. Enter, let's hit play. Now we're in game, we can walk around, and if we run, you'll see our FOV goes out. And this actually looks much nicer to run because it feels like we're actually sprinting. We can set the field of view smoothness to 10. Let's try that to make it even faster. I think that's actually a little bit too fast. Let's try 7.5. Let's see how that feels. I think that's actually a good speed right there. Let's go ahead and end our play mode. Or actually, I'm sorry, let's make a field of view smoothness 2. It should be kind of slow. You don't want it to instantly go. There we go. It should be very gradual. Let's try 3. Sorry, I'm very picky. Oh, 3 is it. Okay, so 3 is going to be our magic number for the field of view smoothness. So set that back to 3, and now we have our field of view changing whenever we walk and run. The next step here is going to be crouching. We want our player to be able to hide behind objects and crouch. This is actually going to be extremely simple. So the basic idea here is whenever we crouch, we want to lower the height of our capsule collider gradually to 1. This will make the player fall down and our camera will still be kind of at the top of the collider. So we're going to change it to 1 whenever we crouch and stand back up to 2. So let's go into our player controller script here. In here, let's add some variables. We're going to add a private capsule collider, and we're going to call this collider. I'm going to move this actually up to our rigid body level here so that we have all components at the top, floats in the center, and vector 3s at the bottom. Next, I'm going to add a header actually above these speeds and make a header and call this speed. I'm going to then create a header here for crouching. We're going to create a public float crouched height, which will equal 1, because whenever we're crouched, we want to be at 1 height on our collider. Next, add a public float for our normal height, and our height will always be 2 if we're not crouching. Next, let's make a float for our crouching speed. So crouching speed. Perfect. Now in our start, let's get a reference to our collider. So we're going to say collider is equal to get component capsule collider. Oh, can't spell. Capsule collider. Perfect. All right. Now let's add a method called handle crouch height. Or private void handle crouch height. In here, what we're going to do is we're going to set the crouch height target. So before we do this, we need to actually add another state to our player movement state enum. So below sprinting, let's add one for crouched. So back to our handle crouch height, we need to say, hey, our float height target is going to equal if our movement state is equal to crouched. So if we're crouched, we'll set our height to this dot crouched height. Can't spell again. This dot crouched height. Otherwise, it'll be this dot normal height. Perfect. Now, we simply want to lerp our collider height. So this dot collider dot height is equal to mathf dot lerp from our this dot collider dot height to our height target, with the speed being our crouching speed times time dot delta time. We can now add this before our actually, let's add this after our handle speed. That's probably the best place for this. So handle crouch height. Now we need to make crouching a thing. So down to our handle input, below our input get key shift for making our movement state shifting, let's add a else if input dot get key code dot left control. If you're holding down left control, our movement state is going to equal our state player movement state dot crouched. Now, if we're crouching, we don't want to be able to walk as fast. We want to have a different speed for crouching. So let's go ahead and add a new speed called crouching speed, or crouched speed, let's call it. So now on our handle speed, let's change this up a little bit. Target speed is going to equal to walking speed. Then below this, we're going to add a switch statement for our this dot movement state. Now, in the case that we are walking, we're going to say target speed is equal to walking speed. And then we're going to break. But in the case that we're running or sprinting, we're going to say target speed is equal to running speed. Break. Finally, in the case that we are crouched, so player movement state dot crouched, our target speed is going to equal crouched speed. And we're going to break that. And there, we now have implemented crouching successfully. The only thing left to do here is to test it. So let's minimize this. Now that we're back into our editor, let's go to our player here, and we're going to change these now. So whenever our crouching speed is going to be 5, the magic number, of course. Our walking speed is 2. We want crouching to be very slow, so you can kind of creep around. So our crouch speed is set to 1. All right, now we can go ahead and enter play mode and test this out. So now we're in play mode, we can walk around, we can run, but we also crouch, and we will crouch down now, and we move even slower. This is very smooth and perfect. We can crouch down, it's very smooth, and it just makes our character feel more alive. So we also need to change the field of view to make it more cramped whenever we crouch down, to lower our field of view, to make us focus more whenever we're crouched. So let's close. Let's go to our camera controller script. Let's go to handle field of view. We're also going to change this up. So we can actually go to our player controller and copy our handle speed switch here. So we can actually just replace this and paste it in here. and change target speed to target FOV. Let's go ahead and Control C, paste all of these. Except instead of this dot movement state, we're going to say this dot controller dot movement state. And our target FOV is going to equal our walking FOV by default. Let's paste that there and change our running speed to running FOV. And then we create another variable for crouched FOV and assign that so. Now if we Control S save and go back into our editor, we can test this out and we should be able to have a different field of view whenever we're crouched. Now that we're back in our editor, let's go ahead and go to our player and change the crouched field of view. I'm going to say 40. We want it to be much more narrow. Let's go ahead and full screen to see the full effect here. Let's hit play. We're now back in. So whenever we crouch, you can see our camera will go in and go out as we crouch. Now, if we were to run, it'll uncrouch automatically, which is what we want. We don't want to lock the player into crouching if they choose. If they need to run in a hurry, then they should be able to just hit shift and run. And if I let go of shift while holding down crouching, we'll go back into crouching. This gives the player much better control over their overall movement. So next, what we're going to do is we're going to implement leaning. We need to be able to peek corners. So let's get to it. To add leaning to our player, we're going to first go into our camera controller, which is going to be right here. And then in here, we're going to, below our field of view, we're going to add a header. Let's call this leaning, not leaning, leaning. And underneath our leaning header, we're going to add a public float. We're going to call this leaning offset multiplier. And then we're also going to add a leaning rotation multiplier. Now actually call it leaning offset and leaning rotation. And then we'll add a public float called leaning smoothness. I like to make myself be able to have control over each of the different mechanics of the player, so leaning smoothness will go right there. So finally, we need to add a private float up here called, it's going to be leaning value. And then let's start the leaning process. So first of all, in our handle input method here, scroll down below where we handle our movement input calculation, which is right here. We're going to add below here, we're going to add this dot leaning value is equal to input dot get axes and then lean. Now this is referencing an input scheme that I've already created, which real fast, so you can go to edit, project files, you can go to input manager, and I went ahead and I added one, 31, called lean. Name is lean, where the positive button is Q, or sorry, the negative button is Q, the positive button is E, and the type is a key or mouse button with the axis being X-axis, and the snap is enabled to true. That is how I set up my key, and that is where I am getting that input axes from. So now we have our leaning value. Now let's actually do some leaning. So this is going to be handled after we handle our input. So we'll add handle leaning, and below our update, let's add a private void handle leaning. In here, we're going to do some things. We're first going to say this dot camera rotation, referencing our camera rotation that we're using to rotate our camera with. We're going to say camera rotation dot Z. To lean left and right, we want to rotate the camera on its Z axis. So we're going to equal this to mathf.lerp. We're going to lerp this from our camera rotation dot Z. And our target is going to be our target leaning. It's going to be leaning target or leaning value. And remember, our leaning value is going to be positive 1, negative 1, or 0, depending on if we're pressing Q, E, or neither. So we want to essentially do 1 times our leaning value times, and then our leaning rotation. After this, we want to do comma leaning smoothness times time dot delta time. Now below the rotation Z handling, we want to do one more thing. We want to lean our camera position to move left and right. So to do this, we're going to say this dot camera position, which does not exist yet, but we're going to say this dot underscore camera position dot X. Let's actually go up here and create this value. So below our camera rotation variable here, let's duplicate, call this vector3 camera position. Now in our handle leaning function, we can say camera position.x is equal to mathf.lerp from our camera position x to our leaning value times leaning offset. And our speed is going to be leaning smoothness times time.delta time. So now what we can do is below our handle rotation, we're going to need a handle position function. And I'm going to create that below our handle rotation at the very bottom. So private void handle, handle position. And in here, we're going to say this.cam.transform.local position is equal to underscore camera position. And that is all we need to do there. So now we are leaning left and right, but we also need to do one more thing. The camera position Y is going to be 0, which is going to bring our camera down to the floor and remove that 1.5 Y offset we have done on the camera. So below this X position set, we're going to say this.camera position.Y is equal to this.cam.transform.local position.Y. And I'm going to add a comment to say fix the Y offset. So we have now implemented leaning. Let's go ahead and Control S save and get back into the editor and edit these values and then play. So now that we're back in the editor, let's go over to the player here. Now let's go down in our camera and set these leaning values. So the values that I have found the best of luck with is 0.25 for the offset. The rotation was set to 5. And for the smoothness, you guessed it, 5. Now let's go in the game and play. So upon hitting E, we lean, but you can notice that we're kind of rotating the wrong way. So let's go back into our script here, and that's because we need to, we need to invert our value here. So what we're gonna do is simple. We're gonna say camera rotation.z, and instead of times leaning rotation, we're gonna do times negative leaning rotation. Let's Control S save, it'll compile, and then let's play test to make sure that this works now. That the camera does lean properly left and right. And so this is, let me go full screen. This is the value that I have found the most luck with because we don't want the player to lean kind of like Rainbow Six Siege where it's a full 45 degree. We want the player to be able to peek behind corners. So hitting E will lean left, Q will lean right. And this gives us a very subtle leaning motion allowing us to peek behind like standard objects like this. We can go, hey, peek out, uh-oh, there's a dead guy there. And it increases the overall spook factor here. So let's go ahead and end our play mode. And now we're going to add our final mechanic, which is running and hooking backwards. This allows our chase and is honestly copied from the Outlast mechanic of staring backwards as you're being chased to make sure that the person is still behind you. So let's get to it. The first thing we're going to do is enter our player camera script again. And this time we need to add another header called header, and we'll say looking behind. How we want this to work is if we're sprinting and we lean, instead of leaning, we want to look behind the way that we're going. So we're going to kind of actually just copy all of these variables here and paste it under here, except instead of leaning offset, we'll call it look behind offset, look behind rotation, and look behind smoothness. There we go. Now, in our handle leaning, we're going to refactor some things. So first we need to check if we are sprinting. So we're going to say bool is running is equal to our controller dot movement state is equal to sprinting. So if we're sprinting, then we are running. So next we need to determine our rotation multiplier. So we're going to say float rotation, and we're going to equal this to if we're running, we're going to make it negative look behind rotation. Otherwise, we'll do our leaning rotation. Now we can say leaning value times leaning rotation. We can replace the leaning rotation with just rotation, no negative needed because we are factoring that into our float here. Before our leaning rotation, let's add a negative sign to make it negative because it does need to be inverted here. Next, let's do it for the offset. So float offset is equal to, if we're running, we want to do the look behind offset. Otherwise, we're going to do the leaning offset. And then replace leaning offset with offset. Now we want the smoothness to be changed too. So float smoothness is equal to is running. We're going to say the look behind smoothness, otherwise it'll be the leaning smoothness. We'll replace leaning smoothness with smoothness, just our generic variable there. And there we go. So if we go ahead and save this now, let's go back into our game. That's all we actually need to do there too, which is very nice because it's just going to modify our additional values there. Now, if we go into our player after this compiles, we're going to have to set the look behind offset, rotation, and smoothness. And I actually already have these values predefined here. So let's wait for this to complete the domain, and then we will go ahead and edit this. There we go. Let's go player. In the look behind rotation, I have found that 145 is the perfect amount because we don't want to look 180 degrees behind. 145 gives us the idea that we're looking over our shoulder a little bit. The offset, we want to go a little bit more grand of 0.5 to look around our head. Smoothness, I found 10 is the best value. So now we can go ahead and hit play. So we can lean left and right as normal, but if we're running, we can look. Now, what is happening there? We're rotating on the wrong axes, which is not good. But at least if we're running, we can do it and it'll go both ways, but that's not the way we want to do it. So let's go ahead and exit play mode, go back into our script, and this is where we need to change a few things. So the Z rotation is going to rotate it on the Z axis. We don't want to rotate on the Z axis for this, but we do want our player to actually lean as we're turning our head. So let's add another parameter called look behind. Instead of rotation, let's call this look behind leaning rotation. And instead of the rotation being the look behind rotation, we'll go the look behind leaning rotation. Now let's make another float called float y rotation is equal to, if we're running, it's going to be the look behind rotation. Otherwise, it'll be 0 because we don't want to look behind us whenever we're leaning normally. Next, what we can do is we can set our y rotation. So we can say this dot camera rotation dot y is equal to mathf dot lerp from this dot camera rotation dot y to our y rotation with the smoothness times time dot delta time. And that is all we need to add, and this should now work as intended. All right, now that we're back in our game, let's go to our player. Whenever we're leaning out or whenever we're staring behind, I want to make our rotation 25. It needs to be more obvious that we are tilting our head. So there we go. Let's go full screen to see this, and let's hit play. Now that we're in game, we can run and we can look behind us. Now, we are noticing an issue here. We are, if we run, looking behind us instantly, which is not how we want to do it. So let's exit real fast. Let's go in here. And now we need to do something else. We need to say camera rotation.y. We need to multiply this y rotation by our leaning value. So leaning value times rotation, times y rotation, not at, and times y rotation. But this is going to create another issue because whenever we press E, we're going to lean right. But if we're turning 145 degrees, E is going to look behind us in the right way or in the right direction, making our keybinds inverted. So we need to invert our leaning value. So let's make another float called lean value, and that's equal to is running. If we're running, it needs to be negative leaning value. So if it's positive 1, it's going to be negative 1. Otherwise, it can be its standard leaning value. Instead of doing leaning value times rotation, we will do, not exclamation, negative. We can do lean value instead of leaning value times rotation, times y rotation, and times offset. We can notice immediately that the y rotation is actually, the y rotation needs to be flipped. So the way we're going to do this is we're going to do negative on the look rotation, negative look behind rotation. This ensures that now we'll actually look behind in the right direction, according to our leaning value. Back in the game, we can go ahead and look, and we actually do look in the right direction. If we hit Q and E while we run, we can actually just look behind us entirely. But we are going to notice one final issue is that if we go up to a wall and we crouch, it'll get stuck until I let go of my W key. Then it'll go down. This is because our character controller has some physics issues that we need to resolve. So let's end and let's quickly go into our project folder. And let's create a new folder in our project parent folder called physics. In here, we need to create a new physics material, which is going to be physics material, and we're going to call this player physics. In here, we need to set the dynamic and static friction to 0, with the friction combined being minimum. And here in our player capsule collider, we can go ahead and drag this on, go back into our view and hit play. And now whenever we go and we move into this wall and we crouch, it will work without getting stuck in it anymore. And there you have it. We have now our simple character controller that we can run around with, look behind us as we sprint, we can crouch, we can lean left and right, and so on. In the next video, our goal will be to actually add a function of camera shake as we run. Whenever we run, we don't want it to look very smooth. We want it to look very panicked, and we want to shake the camera as we move. Also, maybe a tiny bit as we walk, and even slower as we crouch, to give our player a sense of, movement and weight. We will also be creating a chase sequence where we will have an enemy chasing us and will get us. If you guys enjoyed, please leave a like, be sure to subscribe, leave a comment. If you have any questions, I will get to them as fast as I can. And until next time, I will see you guys in the next video. Later.